In the previous video, we talked about finding a 95% confidence interval by using twice the sampling distribution standard deviation to figure out how far away from the center we should make our interval. But in this video, I want to talk about what if we wanted to adjust our confidence level to say 90% or 80% or 93%? How do we do that? And the essence of how we can do that is by using Z-scores in a Z-table. Because remember, the Z-table tells us how much of the data falls underneath, say, a Z-score of 1 or 1.5, and it gives us a percentage basis for any score. And essentially, we can figure out a confidence level using a Z-table. And let's go back to the slide so we can walk through how that works a little bit better. But another excerpt from our book kind of explains, well, what's the critical value, which is called Z-star. So there is a difference between Z-score and ZStar score, but it's kind of the same idea as we did from chapter 3. But a critical value has to do with the confidence level instead. So instead of relating back to probability beneath the curve, because remember what a Z-table does is it tells you what's the probability that it lies underneath this particular portion. This score actually tells us, we want to know what's the probability within the hump, because, you know, like a 95% confidence interval, we want to know how many standard deviations do we need to encompass that particular part of data, which is given by Z-star. So say, for example, with a 90% confidence level or a 95% or a 99% confidence level, those correspond to critical values of 1.645 or 1.96 or 2.57. And if you're wondering, what does this mean? What do these scores mean? Basically, let's go ahead and look at what those Z-scores represent on the particular table and kind of talk about why that would be. But there's a tip that I wanted to share with you, is that if you want to figure out where to look in your table, basically, how do you determine the Z-score from the confidence level? You can do the confidence level plus 1 divided by 2, and this will tell you what percent you're looking for in the table. So this is like the trick for finding it. So let's say, for example, 90% confidence interval. I want to figure out what's the critical value for that. I could go ahead and plug that into the formula, and I'll talk about why this formula makes sense in a second, but that would be 90%, 0.9 plus 1 over 2. Notice what that would give me is 1.9 over 2, and if we went ahead and did that 1.9 divided by 2, that would give me 95%. And basically, this is the cumulative probability that we want to look for if we're using table A. Now, also, I believe it's table C in our book actually has a lookup value for confidence levels and critical values. But I like to use table A and the Z table to figure this out. But basically, if we want to do a 90% confidence interval, that will correspond to the Z-score of 0.95. And if you actually look at the Z table, notice that's exactly where this lines up. A Z-score of 1.601235 gives us a 95% confidence level. And so why does this have to do with, sorry, this is not a 95% confidence level. This is a 95% cumulative probability. Because remember, what that table does is it includes all of this stuff. But the idea is, if we want to subtract off the left tail, because we only want the probability in the central value as is for our confidence interval, we want to be 90% confident that it's in this part, not including the left. That basically, we want to subtract the remaining percent divided by 2, and that's what I've kind of taken into account in this formula. Because if you take the confidence level is what we want, and we add in this additional part, so basically this is a transition to the Z table. Because this part is what we want to know. You know, what's the Z-score corresponding to the probability that the entry is going to fall within here? And if we add 1 minus C divided by 2 to that, algebraically speaking, that gives us this value. And that's kind of what I'm saying, is this is where you can go look up in your Z table, paste your, use your confidence interval, convert it to a Z-score, and then we can look up the critical value from the table A. Or if you want to take a peek at table C, you'll see it's a little bit more direct. But I'm prefer to do it this way, because I think this is how I originally learned to do it. I don't even actually really remember. But let's do an example. Let's say we wanted to know what is the critical value Z star for C is equal to 80%. But again, reiterating, you can plug your confidence interval in this formula and then go look it up in table A to figure out what level we need to be at. So we would go ahead and take 80% plus 1 divided by 2, and that's actually going to give us 90%. Basically, it's going to cut off half of it. We're short 20%. Notice 90% is if you we're short 20%, cut that in half and add it to it. That's essentially what it's doing. But we want to look up where in our Z table is 90%. Because again, like if I'm trying to sketch out what this means, a 90% cumulative probability would be almost all of the data, right? I'm kind of leaving off 10% of the tail. But since a confidence interval, we want the central value. We want to cut off this 10%. So notice how 80% corresponds to 90% in a Z table because I'm trying to cut off half of it. So if that makes any sort of sense, that's what it means in what we're doing. But again, a 90% Z score corresponds to an 80% confidence level. And that's how I try to remember it. But basically now this would be our Z score or a critical value, Z star. And that would be, we could look it up in a Z table. So in a Z table, we're looking for 90% in table A at least. So actually that's not right there. But if we go into a smaller Z score and look for 90%, it looks approximately 1.29. And actually this one might be familiar to you because we talked a lot about 90th percentile. And that was a Z score of about 1.29. And it's the same thing here. Confidence level, looking for 90%. And again, you could use 1.28 because it's a little bit closer as well. But we generally want to include more than we have, not less, in order to be the correct level of confidence. Anyways, so 1.29, that is our critical value. So that is actually, sorry, that's not the Z-score, that's the percentage, kind of like that mistake. We don't want to have our probability be affecting our critical value, but that I go look that up, and that corresponds to a 1.29 Z-star score. Let's take a quick break from this example to look at table C, because I mentioned how to do a table A, and I wanted to say there is a simpler way of determining a critical value from a confidence interval, which is table C, as it says to do in your book. So if you actually go to your book and you Google table C in the table of contents, you'll get what's called a t-distribution of critical values, something that we're going to be using more in later chapters. But if you actually scroll to the bottom, you'll actually can find a critical value table for particular confidence intervals. So notice if you look at 80% confidence interval, you can find the critical value score here is 1.282, which notice it's pretty close to the 1.29 that we used. It's a little bit more accurate. And again, you can either way would be fine. And then notice if you're looking, say, at the 95%, remember we used 2 standard deviations to estimate a 95% confidence interval, but that's actually not as accurate as we could be. We could be a little bit more accurate if we used 1.96, which is actually the Z-score, which corresponds to that a little bit more properly. But essentially, if you want to know particular confidence levels, notice this isn't going to get you any bit farther. Like, notice there's no 97% or 92% or so forth. So you still have to use the method I described before if you want to solve it. Or you can always use a calculator to do it. But if you get the idea, it's not that hard to actually do. Again, just kind of use this formula and then look it up in table A. But anyways, so to actually find a confidence interval, it's the same exact idea. And this is going back to how a Z-score works, right? A Z-score is equal to X minus mu over sigma. And this is in general. If we were thinking about what would the original score be, like thinking about the mean, we could actually multiply across by the standard deviation. Z sigma is equal to X minus mu. And then if we add mu to both sides, we would get mu plus Z sigma is equal to X. It's kind of like, well, the score that we're looking for based on a Z-score is based on the mean plus the standard deviation times sigma. And actually, that's exactly the formula that we've got going on here. Basically, if you take the critical value and you multiply by the standard deviation of the sampling distribution, this will give you your margin of error for your sampling distribution's mean. And basically, you can remember that a confidence interval is calculated by doing exactly this, taking the sample mean, adding plus or minus the z-score times the standard deviation of your sample. So let's go back and finish our example from before, which was we were on the point where we wanted to determine an 80% confidence interval for mu. And again, notice actually I've pasted this right here on your packet, but we could go ahead and go from here. So here our x bar was 1086. So 1 second while I fix my tablet. If we are, I'll go ahead and copy this here once again, x bar plus or minus z star times sigma over the square root of n. But we know all of these components now. Our sample mean was 1076. Our z star score, our critical value, was 1.29, or again, you could use 1.282 more accurately, multiplied by the standard deviation divided by n, which we already did this above. That was approximately 3.162. And this would give us an estimate of our interval. So again, that should be plus or minus. And again, we could find our margin of error right there, which would be 1.29 times 3.162. That's going to be about 4. And so let's just go ahead and round it off. 1076 plus or minus 4. And this would be our confidence interval. And again, you can leave it written as such, or you could write it as 1072 to 1080, right? It's the same meaning, an interval of numbers that describe where our mean is going to be. And notice that this confidence interval is smaller than the one we got in the previous video, because this confidence interval was a 95% confidence. It's a bigger interval because we're more sure that our estimate would fall in a larger range. But if we want less confidence, we can actually get a tighter range. And the reason we would care about this is, let's say we had a specific range we wanted to report, or we wanted to know if our mean is in this range, we could figure out specifically how confident we are. And we can get more and more confident by restricting the range smaller and smaller.